Hello, everyone. Welcome to the second session of our Cloud Native Launchpad series. Our topic today is Infrastructure as Code, IAC, which is the managing and provisioning of infrastructure through code instead of manual processes. So with IAC, configuration files are created that contain your infrastructure specifications, which makes it easier to edit and distribute configurations. My name is Renu Bhatt, Program Lead for the Customer Enablement team here at Oracle. And our presenters for today are Eli Schilling and Tim Clegg. Thank you so much, everyone. I'll hand it over to Eli now.
Good day, everyone. Thanks for joining us. This is our Day One and Beyond Infrastructure as Code. Let's just dive right in. My name is Eli Schilling. I'm a developer advocate here at OCI. I've actually been around for quite some time, since the very early days of Oracle Cloud, and I've really been excited to watch it grow and mature over the years. And I have a colleague and good friend, Tim, here. Tim, you want to give a quick intro?
Hi, my name's Tim Clegg. I'm a developer within the OCI team, so I'm glad to be a part of this and able to meet with you today.
Awesome. Thanks, Tim. We are going to take a quick review here. So we are going along this journey. This is our digital native launchpad, we're calling it. So last month we did kind of an intro to building and running apps in OCI. We're here today to talk about automating everything with infrastructure as code. And then we're going to go through managing code with various cloud-based tools. We'll talk cloud native with Kubernetes. We'll talk about serverless functions on OCI. And then we're going to finish this series with continuous integration and delivery using OCI DevOps. So make sure you check the schedule and sign up for the future events and come spend some more time with us. Objectives for the session today: we're going to talk about the importance and the value of infrastructure as code, how it's going to help enhance and streamline your provisioning and management capabilities. We're going to talk about Terraform a little bit. We're going to take a look at Oracle Resource Manager, which is kind of a managed service for Terraform. And then I want to make sure that everyone's aware of the choices available out there. So we'll talk about Palumi as well, which is one of the additional infrastructure as code tools out there. So to get started, I'm going to hand it over to Tim, and he's going to take us through some IAC basics here.
Excellent. Thanks, Eli. And looking at the poll responses, or some of the questions anyway, some of you might be familiar with this and some not so much. So we're going to cover, just lay the groundwork, so to speak, in terms of just talking about infrastructure as code in general. Now, on the next slide, it shows kind of essentially in a nutshell what infrastructure as code is, which is where we describe, rather than pointing and clicking and interacting so much directly with the different resources that we have in our environment, it's more describing via a programming language or a coding language, some sort of language in general, what it is that we want to have as far as our resources. And this could be both cloud resources, or it could be on-prem resources or resources in a legacy colo. Now, you might be asking yourself, why do I care about infrastructure as code? Why do we talk about it? Well, several different areas here, some of which might be ahas, some of which might be kind of, okay, I already understood that, Tim. One of those is around speed. It's kind of slow. Pointing and clicking, it's great. It's a great interactive experience, but it is kind of slow. I can code pretty quickly. I can copy and paste code blocks and be able to do find and replace very fast. I can also look and navigate my different resource descriptions or definitions very quickly as well by looking through a code base versus having to type a lot of different commands at a command line or click through an interface or what have you. It's not to say that I don't, but predominantly if I'm going to be managing infrastructure or different resources, I want to do that via code. Another benefit is consistency. So rather than pointing and clicking and hoping that I click the right checkboxes in the right order and save things appropriately, I can do it via code, and I can copy and paste again or reuse modules or libraries, different ways. There's different concepts of how I can reuse code definitions. Now, automating this is super nice. It's kind of difficult to mock or simulate keystrokes and mouse clicks and things like that. But when I have things defined programmatically, I can embed these within automated pipelines very easily. Nice benefit too is around the governance side. If I'm using a Git repo, things like that, I get to be able to see the history in terms of where things have been, which also can aid me if something goes sideways, which of course we never have problems, right? It's always perfect every time. But in
Every
those
time.
situations, yeah, when it does go sideways, I can quickly roll back and it's all in my Git history. And then of course, when we're looking for from a compliance perspective as well, I'm able to analyze the code and be able to assess, oh, this is compliant, this is non-compliant, whether we're doing that manually or programmatically, which we're going to talk about, kind of spoiler alert. Now, you might be asking yourself, okay, this sounds interesting, but I already have existing resources. I already have a big infrastructure. That's fine. The nice thing about IAC is it's really flexible in terms of who can adopt it, because pretty much you can adopt it at anywhere part of the life cycle of a given resource. So if you have a brand new greenfield environment that you're going to be deploying a bunch of new resources for, you can use IAC out of the get-go. Use that approach. If you have an existing brownfield or existing environment as well, you can import those different resources into an IAC tool and be able to manage them. So it is applicable, I think, to pretty much everyone on this call, as long as you're dealing with resources. Now, kind of the next slide talks about, it is a little bit of a mind shift when we're dealing with IAC. It is both a methodology or a mindset, a philosophy, as well as tooling. And a lot of that goes into how we describe or how we work with the different resources. So rather than pointing and clicking and kind of going through the motions of managing the life cycle, managing the different attributes of a given resource, with IAC, I describe what I want the end state to be. This is called declarative. I declare this is what I want the final product to be, or the final state. The IAC tooling that I'm using, and there are different tools, we're going to talk about some of those today. There are others that we won't cover on the call. That's going to be able to, most of these tools, really all of them, keep track of what we call a state. So it's a picture of the world the last time the tool was executed effectively. And then of course we actually have our environment where the resources live, and that's what their actual state is. And so the IAC tools, they compare what Eli has said he wants these resources to be like, to look like, and then the state of what they last were known to be, and then of course what they are today. And then it essentially does a delta between those, being able to say, oh, I need to update this resource, I need to destroy this other resource, and I need to add these additional resources. And it does it in an intelligent way to where I don't have to be aware of dependencies or relationships between different resources. It manages that for me. The next slide, there's a lot here. We're not going to talk about all of it. There are some key decision points when you're assessing different tools, because again, IAC is an approach, a philosophy, but there are specific IAC tools. And so as you're adopting infrastructure as code in your organization or in your environment, these are some of the things you might consider, such as the language. If you already have programming expertise, if you're already tooled for certain languages or data formats, keep that in mind. How is it going to execute? The approach, what vendor support does it have, its ecosystem, things like that. Just for the sake of time, we won't go through all of these, but feel free to look at the slide deck afterwards and refer back to it, because it is kind of, in my mind, kind of a checklist, so to speak, that you can proceed through and just at least consciously cover these different areas to make sure that you're getting the tool that's a good fit for your environment and use case. Now, we were talking about governance just a minute ago. I want to just touch briefly. So we could dive a whole session on just policy as code, but let's look at just what this looks like from a governance perspective. Some things that are possible. I'm going to pick on Terraform just because it's a great candidate here. When we're looking for an environment that we want to maintain a consistent look, feel, we have to maintain compliance, whatever. Policy as code or governance as code is a great approach. And this is a really high level bird's eye view of an automated pipeline where it allows the developer to have really good control over their resources that are used within their environment, but within the constraints and the rails, so to speak, in terms of what's been authorized by the organization or the security team. So developer would have code, they would push it, it would go to an automated pipeline, which would then lint that code, make sure that syntactically it's correct. Then code authorization happens. And we'll talk about some of the different tooling. As we're looking at the different facets, we've included some different tools to look at when you're for some of the different IAC tools out there for this. If authorization passes, things are applied, it's great. If we see a violation though, this could be a naming, could be something that's being done that's not, it's not within a predefined range or bound, then an error gets returned, it's not applied, and it's bounced back to the developer who can then fix the problem and recommit and push and start the cycle all over again. This is all, again, very fast, automated, and easily accomplished with IAC.
So Tim, just a quick question on this policy as code for clarification.
Yeah.
When we set up our infrastructure as code, we can allocate obviously identity and access management permissions to our users who are going to be executing this infrastructure as code.
Yes.
Policy as code, as I understand it, it's kind of an extra level. So even though someone may have permissions to do something, we can restrict that with policy and ensure that we're not spinning up 64 core GPU instances in our dev environments, or provisioning hundreds of admin level users as part of an application rollout, right? That's kind of what the intent is here.
Yeah, absolutely. So IAM is really good about telling about us being able to specify Tim is able to create this resource, but not this other resource. But what I'm not so able to get into are into the weeds around the attributes of that resource. And that's where policy as code shines. I'm able to be really specific. Could be something as trivial as a naming scheme, that we want used or enforced. And that's where policy as code kind of allows us to delve in deeper into those different attributes of a given resource that goes above and beyond what I can do with IAM.
Excellent. Appreciate that.
Yeah, great question.
And where exactly can you use infrastructure as code?
Well, I prefer OCI, Oracle Cloud Infrastructure, obviously, and I admit I'm biased, right? I'm just a little biased. We do have a lot of regions, 46 cloud regions, and we have great interconnectivity with Azure because we recognize that very rarely are you going to be able to put everything just in one cloud for different reasons. And so we have a great cloud offering, and obviously we offer terrific support with many different IAC tools. Now, if you have legacy colo environments or what have you, you can use a lot of these tools for your on-prem or your legacy colo as well. So it's not limited. Many of these tools do not limit you to just cloud, although by far, cloud is where you're going to get a lot of the bang for the buck, I think.
Excellent. With that,
let's talk Terraform. And I saw some responses. It looks like several folks have used Terraform, which is good. So we're going to do a quick overview here. And what we've done is we've broken it up in terms of the language or the format that's used, how it runs, and then some of the different aspects. So with Terraform, it'll take either JSON or what's called HCL or HashiCorp language, or HCL2, which is a newer version. And so you describe things declaratively in this format, which HCL has a very fast, it's very easy to understand and adopt. Clearly, there are complexities like with any tool, but as far as learning something new, HCL is very attainable. And we have some great tutorials I think we're going to include as links here as well that'll kind of step you through a 101 or a beginner series in terms of getting ramped up with that. But it's very easy language format to use. Now for executing it, OCI has Resource Manager, which I'm not going to talk about because you're going to hear about that right after this. Yeah, with Eli. So I'm not going to talk about that. But the Terraform also offers running as a command line tool, as well as a cloud offering as well with Terraform Cloud. Now, what you need to execute it at minimum is you need the executable, so the Terraform CLI, and then the state. And the state is going to be tied to a specific environment, and you'll want to make sure that you manage that and keep track of that. So it's very simplistic in terms of its runtime requirements, as well as versatile in terms of how it can be used. Now, around governance, policy as code. Open Policy Agent, you may have heard of it if you worked with Kubernetes, or may have seen it around. It's a great option here for policy as code or governance as code. HashiCorp Sentinel is another. So there are some tools and some add-ons, so to speak, if you wanted to go down that policy as code route that's available with Terraform. Now, as far as using it, there's a couple of different execution models. So one is using OCI Resource Manager. Not going to talk about this in depth. At the end of the day, push it to a Git repo. Resource Manager then takes it over and manages all of the state, everything there. So that way it's literally a point click or API calls or CLI, OCI, CLI commands to plan, apply, and destroy it. Very easy. All that I have to do is provide my code and tell it I want it to do something. And it really makes it easy. It's the easy button for Terraform. Now, if you do want to be a glutton for punishment, not really, but if you do want to do it through the CLI, you can. And so that's where you need to provide the code and then run the Terraform CLI, run the binary, and then it'll track, it'll create state and all that good stuff. The state at that point would be something that you would have to manage and maintain. So there are a couple of different execution paths or options for it. Now, with Terraform, remember I was mentioning that when you, with IAC tools in general, you typically define them in a declarative approach. So how you want them to be. And the nice thing is I don't have to maintain what needs what's dependent on what, or the order in which things are created. Terraform, the providers themselves have that intelligence built into them, and you can actually view that. So with a Terraform graph command, you can actually have it describe or tell you all the different resource dependencies, and then you can also visually depict them, just as we have a sample picture here, but you can use like GraphViz or something else to be able to render that dependency tree to where you can be able to understand, oh, this gets created before this, and see some of those different relationships. Super powerful, and it kind of makes it idiot proof for me, because otherwise there's so many dependencies to keep track of. It can be challenging, and it takes care of all of that for you.
And this is an excellent point, I think, to illustrate when we talk about the sort of declarative versus procedural infrastructure as code tools, where Terraform doesn't matter what sequence, a declarative tool, whatever sequence your code is in, doesn't matter. The tool figures out these dependencies. If you're working with procedural infrastructure as code tools, you have to know and understand the exact sequence, because it's going to execute in the order you define. So, it's kind of an easy decision for me personally, but others may have a different perspective on that, right, Tim?
Yeah, absolutely. Absolutely. Now, the next slide is we're not going to talk about this again. These are just some commands. If you wanted to, just quickly play with Terraform after this session, these are just some commands. Again, take a look at the learning tutorials. Those will help you, but these are just some of the high level, some of the most basic commands. There's a ton of them out there, so we won't dwell on it. With that, did a sneak peek, a teaser into Oracle Resource Manager. So I'm going to hand it off to Eli to talk about Oracle Resource Manager.
Awesome. Thanks, Tim. Good stuff on the Terraform front. And to keep that momentum going, Oracle Resource Manager, as I mentioned, is it's a managed service for Terraform. So one of the key pieces here, and we'll get into the functionality and the capabilities in a moment, but Tim mentioned, all infrastructure as code is really based on state. So the state of my environment as resulting from my infrastructure as code execution. If you're running a tool like Terraform via the CLI, it generates the state file locally, and you have to make sure you take good care of that state file. You have to store it securely. You have to make sure it's accessible to multiple users if it's being actioned by individuals in a team. If something happens to the state file, it does impact the state of your environment potentially. So Resource Manager is going to, in addition to all the other functionality we'll talk about, take care of that state file for you. It's going to store it in a secure, redundant location. It's going to ensure that you can only execute a single job at a time. That way you don't accidentally overwrite or have actions stepping on each other and resulting, in some sort of incorrect state file. So that's kind of the key piece here, is making sure that when we're using infrastructure as code at an enterprise level, we have a protected state file, and it's going to be maintained by the service. So within Resource Manager, we're going to create what's called a stack. The stack is basically a collection of resources as defined by our Terraform code, and then we can run jobs against that stack. So plan, apply, destroy, and import state, as you can see on the file here. We'll take a look at the console here in just a few minutes as well, and we'll kind of walk through exactly what that process looks like. Here we have this sort of continuous cycle, this flywheel. So we're going to start by either collecting some sample templates, or we're going to write our own Terraform configuration. Maybe we'll even import some existing resources into Terraform code. We're going to take that to our Resource Manager tool, create a new stack. That could be done via the console. So we'll do the UI version a little bit later here. It can also be done via the command line interface or the OCI SDKs. So again, from a scripting and automation perspective, Resource Manager provides all these benefits, but you don't have to use the console in order to leverage Resource Manager. You can use the OCI APIs to interact as well. So once that stack is up, we will execute our jobs, whether it's plan, apply, destroy, or import state. And then you can view the output, you can see the results, the resources, the parameters, and then again, we kind of come back to the beginning. You can update your code, you can make changes to resources, apply those, basically bring that updated code back into Resource Manager, and then apply again to alter the state of your environment. If you're just looking to get started with Resource Manager, or maybe you're kind of interested in some existing quick start solutions, we do have the Solution Hub. And this basically consists of a collection of existing Terraform examples. So there's some demos out there, there's some basics for new users getting started, and then we have some best practices kind of around, common application patterns, common usage patterns for Terraform. I do want to just take a quick segue over here. Also have this resource, this architecture center. And we'll poke around a little bit later, but basically our architecture center has a whole bunch of pre-built solutions as well, where I can actually go right to GitHub and I can see all of the Terraform code that was generated by our teams for this particular solution. So this is another great place to start if you want to get, kind of get your feet wet, dip your toe in the pool, and experiment with Terraform a little bit if you're kind of new to that technology. Another capability here with Resource Manager is the notion of private templates. So the consistency and the reusability benefit of infrastructure as code. Private templates gives us the ability to create reusable content that can be shared internally with our teams in a private fashion. So I can designate, dev environments. I could designate certain maybe ephemeral environments that we need for weekly or monthly reporting processes, create the templates for those, and then make them available to the requisite teams to be able to provision those templates into a stack, generate the resources they need for a period of time, and then discard those resources and move on. So this is kind of a central internal repository for reusable Terraform code. Now, the resource discovery, this is, as Tim mentioned earlier, you can start kind of anywhere along the way. If I already have infrastructure and I want to start utilizing infrastructure as code, we can actually point Resource Manager to a compartment inside of OCI, and it will generate the Terraform code for me based on the resources in that compartment. So you can see the example screenshot here. I'm going to point to an existing compartment. I'm going to basically give the stack a name, and it's not in the screenshot, but you can also select the services that you want to be in scope for that discovery. So if you just want to detect networks and compute resources, you can do that, or you can detect everything. Resource Manager is going to spit out, as part of that stack, the whole set of Terraform code. And then you can start with that to tweak and adjust and begin to then manage existing resources via infrastructure as code from that point forward.
Now, Eli, so once you do discovery, and let's say I had an existing environment and I did discovery, do you want to keep managing it, clicking in the console, or do I want to do it just with the RMS? Like, what's the best practice, I guess, in terms of like once that discovery is completed?
That's an excellent question, Tim, and I'll maybe take a step back in terms of talking about best practice. Moving to an infrastructure as code methodology or culture is really kind of a switchover, right? We want to try to get away from doing things manually. We want to try to make sure that, just like our software, our code, if you're delivering new features and new functionality in your application, you don't want people going in and making those changes manually or tweaking the code without checking it into your pipeline and going through the formal process of evaluating what that change will impact and how it will result in the eventual infrastructure. So the idea here is, as we're experimenting with infrastructure as code, we might kind of do both. We're going to be managing our production environments by hand, and then working and learning to manage non-production environments with infrastructure as code. Once you implement an environment with infrastructure as code, the best practice is to stop making manual changes. If you need to alter a resource, add a resource, remove a resource, do so in your infrastructure as code, apply that to the environment. That way, two benefits. One, you always understand what's going to be happening what change is going to occur. And two, your code will always be a relevant example of what the environment looks like. Again, it's declarative. So if I code my environment to be a collection of resources, and then I apply that, my code defines what my environment looks like. And not saying it always works, but there are visualization tools. So you could take that infrastructure code and actually generate a diagram of what the environment looks like, to the point where, you know, auditors looking for Visio diagrams would potentially be satisfied by, here's my environment. So excellent question. Appreciate that.
Thank you.
A few other things here. So we have external integration. I showed an example of using GitHub for some of our public templates, public examples. And, you know, same thing, if you want to use GitHub, GitLab, or even object storage for your configuration, your code, you can create these integrations inside the Resource Manager console, and then you can consume that code directly from the source control, the SCM tool, as opposed to having to, you know, move folders around and track that code manually. Terraform does offer a drift detection capability. So again, if you've implemented infrastructure as code and somebody makes a manual change to a resource, drift detection is going to identify that the state file that we have doesn't match the live state of the resource. So it's going to basically go look at all the resources, do a diff against the state file, and come back saying, we found something, right? We've noticed here the core instance has been modified as a result of our drift detection. We take a look at the actual properties, and the actual properties here show the agent config is management agent, but the actual expected properties, our code has defined it as a plugins configuration. So now we have to decide, okay, which is appropriate. Was the manual change authorized, and now we need to update our code, or was the manual change unauthorized and we need to roll back the change and go with what was previously defined in the code. One of the pieces here is the private endpoint management for Resource Manager. So, you know, security being kind of the name of the game, where we want to deploy resources into private subnets. We want to prevent direct public internet access for various resources in our environment. But during the provisioning process, we might still need to be able to access that resource from Terraform to run scripts to do provisioning, configuration, or other activities. So the private endpoint management allows us to basically let Terraform in to that private subnet temporarily to access the resource for remote command execution or other tasks. Now,
and what are
no, go ahead. I think you're going to ask the question I was about to answer.
Well, maybe. I was just curious, like, what are some common use cases, like different types of resources, or where might I commonly use this functionality, you know, this feature?
Yeah, so, you know, one of the most common is I've spun up a compute resource and I need to do a remote SSH command. I'm going to drop some files onto that server. I'm going to run some configuration. And again, it's in a private subnet. I can't access it from the internet. I can't access it from the resource manager control plane. So I need to basically create this, this private endpoint inside the subnet through which those Terraform or those resource manager tasks can be executed. So like we have on the screen here, remote exec is a provisioner that's available in Terraform. Maybe you're looking to access some code or some binaries from a private Git server. So again, that endpoint would be able to access those resources, assuming that you've configured your network accordingly, because this behaves just like an endpoint inside the network. So make sure your security lists are configured properly, your route rules, allowing that endpoint access to the requisite resources.
Got it. Okay. Thanks.
Thanks. Another example here. So this is kind of a best practice with Terraform, creating modules that are reusable to, again, generate consistency within our environment. If I'm going to be creating Kubernetes clusters in a variety of my environments, I probably want to put some guardrails around how that cluster is being created. So I can still pass variables to define, size and shape and whatnot, security controls. But overall, the cluster itself should be fairly consistent. So I can generate a module like we have on the screen here. And I'm not going to talk through all this. It is a bit of an eye chart, but basically the module can be referenced in my other Terraform config. You can see here that module lives on GitHub. I pass a set of predefined parameters into that module, and then it's going to generate or create that Kubernetes resource, basically the same every single time, with the exception of if I change the shapes, the pool, the size, but the kind of the look and feel of that OKE cluster is going to be the same every single time because it's based on a reusable module. One more thing here. So Resource Manager, if you're leveraging the OCI console, we have what's known as a schema overlay. Basically a YAML file that you define. It goes into the parent, the top level folder with the rest of your Terraform config, and it's going to create a custom resource manager in the console. So if you need to request particular variables and input from your consumers, your users, the schema overlay is going to give you a flexible interface through which to request those variables. At the very least, I have static variable definitions where you can see here I want the region, the compartment OCID, and the image name. Now, take a look at the variables here under type for compartment OCID. We actually have about a dozen different types that are built in here. And so I don't need to create a list of variable options. I simply specify the type of compartment ID. And then in the console, OCI automatically gathers all the compartments that are available to this user running this stack and presents them in a dropdown. So all I do is pick the compartment name, which you see here in this case is Eli_S. And then behind the scenes, we're populating the actual compartment OCID to be used with this particular stack. On the other hand, we can use this functionality for dynamic variable presentation. In this example, if I have a compute shape that is not a flex shape, I don't need to ask for OCPU and memory. So in this case, if I've selected something like VM standard 2.1, that's the only option. I move on and I'm done. If, however, I select something like VM standard E3 flex, the schema overlay is going to detect a requirement here. It's going to unhide the number of OCPU variable, and it's going to allow me to select what option I want for that particular variable. So we'll take a look at kind of how this works, but it's a great way to enhance the experience working within the OCI console for Resource Manager. I'm going to take a quick pause as we go into the demo here. The Resource Manager state file is essentially stored in an Oracle managed object storage bucket. So highly available, fault tolerant, etc. And does Resource Manager operate with Terraform only, or can it be used with Ansible? So Resource Manager is Terraform specific at present, but that's not to say that you couldn't utilize the local exec or even the remote exec command provisioner within Terraform to execute Ansible configuration tasks. Ansible is not deployed within the Resource Manager runner, essentially, but you could deploy it onto your hosts and then download the playbooks from the requisite private repo and then execute those playbooks with remote exec, something like that. So you can get creative. All right.
Robin asked one more question. I think, Eli, it's probably worth discussing. And I chose to answer this live just because it's a little more involved. Typing it out would be kind of a little bit of a challenge. Using resource discovery when importing resources, I have found the problem that critical resources like IAM policies get imported and become part of the Terraform plan. If the plan is destroyed, it removes those critical policies. For example, like the tenancy admin policy. How can we prevent this? Great question. Let's talk through that if we can just for a minute here. You were mentioning in the Terraform discovery, right, the importing process, that you could filter to certain types, resource classes, right? Mm-hmm. In my mind, that would be one of those things where you'd want to potentially exclude certain things. Because here's the kicker: when Terraform runs, or when Resource Manager runs, whatever's in the state and whatever's in the config, right, the code essentially, when we tell it to destroy, it will go ahead and destroy those objects. So if during the import process we have discovered certain shared resources, like a shared IAM policy, things like that, it's going to destroy them just because we asked it to. So the key is, in my mind, excluding those from the state and the config of that IAC, or that stack, right? And I'll let you show.
Yeah, I was just showing the ability to select, particular services. So you could basically go through and select the services that are not IAM resources, and it would not capture those.
Yeah.
There's another option as well, and I don't have a code sample, but there's an on delete configuration parameter in Terraform. So you could actually, once you do this discovery and you generate all the Terraform config, you could go in to any of the IAM resources that you don't want to delete. You can add that on delete flag and basically say, don't delete. So when I delete my stack or I destroy my stack, Terraform will skip any resource that's defined with the on delete. I don't remember if it's preserve or don't delete. I forget what the exact syntax is, but you can tell Terraform basically, when we destroy the stack, skip this resource, and then all of those IAM resources would persist.
Yeah. She's mentioning if you choose compartment, I think that's still, if you choose a compartment, that's still there, right?
Yeah, so if I choose like training, for example, I can still pick all services or just selected services.
Got it.
I can select all, and then I can go in here to identity.
Yeah, exclude it.
I think, yeah, and just make sure to undo those.
Awesome.
Cool.
Awesome.
Good questions. All right. So I just wanted to run over here. I think for this example, we're going to start with the architecture center. So as I mentioned earlier, there's hundreds of pre-existing reference architectures defined, most of which include the source code and the option just to deploy right to cloud. So I click this button. If I'm not already logged in, it's going to take me through the login process. It brings me into my OCI tenancy. I simply have to accept the terms, and you'll see here it's going to create an OKE cluster with an autonomous database. Has some info here, and we'll go next. Now this is that schema YAML, the schema overlay that I talked about. So this is the type compartment OCID, and it just gives me a nice list of compartment names. And if I click training, for example, behind the scenes, it's going to actually input the OCID into my code. I can pick my availability domain again, because this prefix here, this 4-character prefix, is unique per tenancy. I don't have to go track this down. This is another built-in type, and I just pick the AD that I want to use. If I want to deploy ATP, autonomous transaction processing, I click the button and it's going to ask me for all the feedback, all the details here. So we'll give it a password. Oops, that's right. There we go. If I want to enable data guard, all the different options here, basically, I'm good with that. And then if I show advanced options, this is for my OKE cluster. I can specify OKE version, node version, and a bunch of stuff. So again, here's all the resulting details. I hit next. No thanks. And if by default, the run apply is checked. So if I hit create, it's going to create the stack and automatically run the apply job. And I'm not going to do that because I actually already did that earlier. And so you can see here, once my stack is done, the apply was successful. I can view the state file. And so you can see here all the resources that were created. You have the OCIDs, all the details of my environment. I have the variables that I put in during the create process. So compartment OCID, region, tenancy, node pool information, my ATP password. I can check my outputs. So if I had outputs defined in Terraform, you can see the resources here, and so on. So a couple more questions. Without Ansible, how are we supposed to configure the instance after it's done provisioning? So it kind of depends on your practice. You can use remote exec commands to go in and do remote SSH, install. You can configure resources. You can use cloud init. So inside of Terraform, you can define a boot up script so that when the resource comes up the first time, it goes through the install and configure process based on a custom shell script. So there's a number of different ways you can do it. It just kind of depends on, you know, how much configuration you want to apply to the resource. Tim, any thoughts on that?
Yeah, there's so many different ways of doing it. You know, do you have, sometimes we'll have an automated pipeline that would be, you know, run out of, you know, some CI/CD environment, right? There's a platform. It could be OCI DevOps, it could be GitHub, GitLab, you know, choose your poison here, right? There's a lot of different ways we could do that. That could make a call to RMS, make an API call, trigger RMS, and then we could have subsequent calls after the resource was provisioned, which would then kick off like a configuration management portion, which could be using Ansible or Puppet or Chef. We could potentially use like remote exec. That's kind of a little bit of an abuse, but it's common, right? Oftentimes, or like you were mentioning, like the cloud in it. So many different ways of doing it. RMS does not have to be the exclusive tool in use within like an IAC toolkit though, right? It's more focused around the infrastructure side, not so much the config management. And so just as there's certain, you know, I can find config management tools, Ansible, you know, Chef, whatever, where I can manage my resources, my infrastructure, but it's not its sweet spot, you know, and so, and vice versa. And so there's no one size fits all for that. It kind of is very, unfortunately, very kind of subjective in terms of how you want to do it. The good news is, yeah, lots of options. Just no one size, you know, no one answer, no one right answer.
Excellent. Thanks, Tim. And I just put in the Q&A here, there's a reference architecture for deploying Jenkins. If you want to take a look at the code, there should be some details in there on how it's actually configuring that VM with the Jenkins stack. All right, so I think we are good on that. Let's jump back over here. I want to talk about Palumi a little bit. I saw there were maybe one or two folks that raised their hands when we asked about infrastructure as code tools. Palumi is another one of those that you know, provides a lot of the same functionality as Terraform. But it basically lets you use your own preferred language. So I don't have to go out and learn, you know, HCL or JSON if I'm not familiar with those. I can pick up TypeScript, Python. I saw a lot of folks on the call today are Python aficionados. I'll put myself in that bucket as well, since we're going to do the demo with Python today. But again, I can define all of my resources with the language of my choice. I can leverage the Palumi CLI, or they have an enterprise version as well, kind of like the HashiCorp Enterprise for Terraform. And when I go to run this, I'm going to take the executable. We're going to generate a state file. We'll take our code, and it's going to create or destroy the resources depending upon the set of actions we're going to run. And of course, from a governance perspective, Palumi does offer cross-guard, which is kind of like that policy as code, to make sure we can assign some guardrails to our infrastructure as code methodology and ensure folks, even though they have access to do certain things, you know, they're still creating resources, defining naming standards, applying tags, et cetera, based on our corporate standards. And so that's one of the tools we can use to help enforce those requirements. As far as running Palumi locally, pretty much the same as Terraform. We're going to install the Palumi tools. We're going to collect the provider, whether it's you know, OCI or Azure or whatever cloud or end product you're using. We're going to write the code. We're going to assign a task, whether it's, you know, preview, up, down, destroy, and then after Palumi creates those resources, it's going to generate the state file as well. So we now know what we've declared, what we have, and we can diff anytime we change the code going forward. So pretty much the same. I mean, very similar to Terraform. We create a new project. This is one of the nice things with Palumi, that you can kind of define different projects in the same space. So I could have a dev, a QA, a production, and then I can easily switch between projects when I'm going to generate and alter my resources. So the projects themselves are kind of like resource manager stacks, if you will. I know it's kind of a quick intro, but it's a little bit easier to show versus talking through it here. All right, so I have Oracle Linux 8 machine. I've installed Palumi. Basically, if you take a look at the directory here, I have my code. I've created a set of variables for my access. So kind of like the OCI CLI, where you have your API signing key, your user OSID, your tenancy OSID. You do the same thing for Palumi. And so I've already input those with the Palumi config set command. So we'll not go back through that, but they're basically stored in the project. And I've got a little bit of code here that's just going to create a VCN subnet and an internet gateway here. So if I do a Palumi preview, you can see here, it is going to create the stack. It's going to create the VCN, the internet gateway, and the subnet. And there's a bunch of random, not quite sure why that keeps popping up. I think I screwed something up in my config, but we can just ignore that. Palumi up. It's going to, again, this is what we're going to create. Are you sure that's what you want to do? And we'll just use the arrow up. We'll say yes. And it's going to go out and it's going to create those resources. And if we go back into our network resources here, you'll see we have our OCI Palumi test. We have our subnet, our internet gateway, and some default resources. Now, if I want to go ahead and extend things a little bit, I'm just going to go grab a little more code over here off screen. Go down to the end. And basically, we're going to define variables for the resources that were created above. So the demo subnet ID and the demo VCN ID. We're going to define a variable for our Kubernetes subnet or Kubernetes version. And then we're going to create a Kubernetes cluster. So at this point, we're not creating a node pool, just the cluster itself, just the overarching cluster. So if I save that, do a preview, we're going to see that we're basically just going to create one new resource. The outputs of that will be the cluster OCID. Now, I'm going to kind of end the demo here because it will take about 4 or 5 minutes to create the cluster. But at the end of that, you would see the output, the details of the cluster cluster OCID, all the requisite details that go along with that, and then again, my state file is updated. And if I wanted to make changes, I would have to alter my code and run Palumi up again. So I am going to jump back over here.
So Eli, I want to
can
I ask you a quick question on Palumi? So the language supports a lot of different languages, right, that are kind of industry standard languages. SDKs are available for a lot of those same languages, right? OCI SDKs. I could do this in Python using the OCI SDK. Why would I choose Palumi or the SDK? Kind of maybe compare and contrast.
That's a good question. So rather than use Palumi, you're suggesting just write the Python code with the OCI SDK to create the resources.
Or why wouldn't I, right? Like what benefit, why would I choose Palumi instead of using the OCI SDK?
Actually, it comes back to what we talked about earlier, the kind of declarative versus procedural, right? Palumi is going to interpret the resources you've defined in your code, and it's going to evaluate dependencies. It's going to evaluate the state and the availability of those resources. I can absolutely take the Python SDK and go define a whole set of resources and run that Python code, and it'll create the resources for me. But now I need to track the state of those resources myself. I have to define the dependencies in my code. So if my code sequence is incorrect, or if I screw something up, I potentially run into issues where I try to create the subnet before the VCN is there. I try to create the Kubernetes cluster before the subnet's available. So when I use the OCI SDKs or even the OCI CLI, because I do this a lot, I do shell scripting quite a bit, you are responsible for the sequence, the dependencies, the state of the resources. You have to track and check all of that. Tools like Palumi and Terraform and Resource Manager, they handle it all. You just define what you want, you let it go, and the tool takes care of the rest. So all the heavy lifting is off the plate.
Nice, great, awesome.
Question in the chat. As I understand it, Resource Manager uses some sort of Docker image to run Terraform. I don't know that we mentioned it being a Docker image, but there is I call it the Resource Manager runner. There's basically a resource behind the scenes that's instantiated with Terraform and some other tools. It is not currently possible to customize that runner. So if that's a requirement, please let us know. I've got an open feature request to the product team. We'll +1 that a few more times, but yeah, let us know if that's of interest. All right, so I hope everybody found this interesting. Tim and I think this particular topic is near and dear to our hearts. So had a lot of fun spending some time with you today talking about infrastructure as code, Terraform, Resource Manager, Palumi. There's several other tools out there as well. I know when we asked the question early on, some folks had clicked other. So I'd be curious to hear from folks what other tools they're using for infrastructure as code. But it's a really interesting topic, and whether you're using Terraform or Resource Manager or Palumi or Crossplane or any one of the tools out there, I hope that everyone agrees it's definitely a benefit. It helps to offload some of that administrative overhead, and it's definitely a fun topic to talk about. So thanks so much for spending some time with us today. Tim, thank you so much for co-hosting with me. Renu, thanks for your support. And I think I'll pass it back to you, Renu, to take us home.
Thank you, Eli and Tim. Great session, and I hope everyone enjoyed this and learned something new today. And for any questions, you can email us at personal-trainers_us@oracle.com. We'll be more than happy to direct your questions to Eli and Tim. Again, thanks again for joining us. See you all next time. Have a great day, everyone.